looking here to solve radical equations, and basically we're trying to get everything out of a square root. So to get out of a square root, it means I got to be squaring both sides. Square root and square cancel each other out, leaves you with x minus 7 equals 16, which gives you an answer of x equals 23 when you solve. Pretty straightforward, not too bad there. You can't square, though, until you have that radical by itself, which is the issue here in this problem. So first, you're going to add 2 to both sides, and then divide by 3 gives you x plus 1 equals 3 divided by 3 is also 1. So now we can square both sides, leaves you with x plus 1 equals 1 squared, which is 1. So subtract over and you get x equals 0 in this case. So two pretty easy examples to start off. Number 3, same idea. This is a cubed root though. So instead of squaring both sides, we have to cube both sides and make sure you are properly doing that cubing. So when we do that, those cancel. You're left with 2x plus 3 equals negative 8. Subtract 3 from both sides, so 2x equals negative 11, so x equals the fraction negative 11 over 2. And this last one, so kind of like number 2, we first need to subtract over the 7 and divide by 3 gives you 4x minus 5 is going to equal negative 6 divided by 3 gives you a negative 2. So what we would be trying to do is squaring both sides at this point. The issue is we have an equation now that already we know is not true. No solution will exist. A square root cannot equal a negative number. Okay, we can deal with like i's and imaginary things. We'll do that in Algebra 2. We won't deal with that here in pre-calc world. We keep it real again. So when you get a square root equaling a negative number, we just know that this is a equation that does not have any real solutions. Okay, now the other thing we need to look at besides these square roots are things called rational exponents. So it works kind of the same way, we're just writing it a little bit different way. So remember, power over root. So really what this is saying is x is being taken to the third power and to the second root is equal to 27. Okay, so we can leave it in this rational form in yellow, or we can change it to this form in blue and solve from there. When you solve this equation, the way it's going to look is you would be, well, to get rid of the square root, you would have to be squaring both sides. And to get rid of the cube on the inside, you'd have to be taking the cubed root of both sides, which would be the third power. So really what you're doing is, if we go back to our original equation, you're really raising it to the second power and third root on both sides. Second power and third root. Because when you do that, you have power to a power. Well, this becomes, you multiply it, so you get 6 over 6. They cancel out, and you're left with just x equals something. So what we have is x, or 27 being squared and then taken to the cubed root. Well, it's always going to be easier, guys, to take the root first. The cubed root of 27 is 3. So that means we're left with 3 squared, because of that 2 up top, which gives you 9. Okay, so let's look at another example. I'm going to raise this to the 4 over 3 power. That way my exponents cancel, and I'll be left with x minus 27 equals some number. So again, let's do the root first. The cubed root of 64 is 4, so we'll have 4 to the 4th power. 4 to the 4th power is a big number. 16 times 16 is 256, so we have x minus 27, which is 256, so add 27 to that, and we get, what, 283 for your answer. Alright, one final one here. We got to subtract 3 from both sides first. So 2 equals 4x to the negative 1/6 power. Divide both sides by 4. 1/2 equals x to the negative 1/6 power. Now, there's a couple of different ways you can solve this. Here's the way I like looking at this. Right now, I have a negative exponent. If I flip a fraction, taking something to the negative first power is what flips a fraction. So if I do that, my right-hand side, to get rid of the negative, it now says x to the positive 1/6 power. To do that, I have to flip the fraction on the other side. And now I'm not dealing with fractions anymore, which again I think makes it a lot nicer. Because now I can solve just straight up with this problem. That, okay, to do that, I'd go to the 6 over 1 power on both sides. So the right-hand side is now just x. I have 2 to the first root, which is 2. 2 to the 6th power. 2 to the 6th power, which you multiply out, should give you 64. So there you have it, a way to work with both radicals and these rational exponents.